Okay, let's unpack this. You know that feeling, right? You're trying to get an AI tool to do something genuinely complex, maybe pull data, run code, summarize it, and it just stumbles.
Yeah.
It hallucinates a function that doesn't exist,
Oh.
or it loses track of the steps, or just completely loses the plot halfway through.
Absolutely. Those moments can make even the most hyped models feel less like powerful assistants and more like,
Yeah,
expensive toys that break easily.
exactly. Expensive toys.
And that pain point, that inconsistency,
Uh-huh.
the unreliability when you move beyond just simple chat, it's been a real frustration.
All right.
Even with models like OpenAI's O series or, Gemini 2.5 Pro, pushing boundaries on context size, getting them to reliably execute complex multi-step workflows, that remained a big challenge.
And that's precisely what we're diving into today. We're taking a deep look at Anthropic's Claude 4.
Hmm?
We're pulling insights from a recent article that really dug into its features, its pricing, and how it stacks up against competitors, like right now, May 2025.
Yeah, and our goal here isn't just to read off a spec sheet, right? It's to understand what Claude 4 is positioned as.
Okay.
Why Anthropic launched it with this particular focus now. What's technically different under the hood.
Right.
How the article reports it performs, both in benchmarks and, crucially, in real-world use. And, ultimately, what its arrival means for how you might build and work with AI soon.
So, moving beyond just the specs.
Exactly. The article really makes the case that this isn't just another model update. It's pitched as core infrastructure.
Infrastructure. Okay.
Designed specifically to tackle that fundamental reliability issue that's been holding things back.
Right. Moving past that clever toy phase, like you said, towards something you can actually build serious stuff on.
Precisely. It feels like addressing that shared frustration was the real driving force here.
So let's meet the lineup then. Anthropic rolled these out May 22nd, 2025. The article talks about two public variants, Claude 4 Opus and Claude 4 Sonnet.
Yeah, and they're presented with pretty distinct sweet spots. Opus is the powerhouse,
The big one.
right, for the really heavy-lifting deep research, sophisticated agents, complex coding projects.
Okay.
Sonnet, on the other hand, is aimed more at, daily productivity, mid-tier coding, lighter agent work.
Makes sense.
One thing they share, though, is a pretty hefty 200K token context window.
Which is still really big, and you see that split reflected in the pricing the article laid out.
Definitely. Opus is pricier. 15 per $1 million input tokens, 75 per $1 million output.
Wow, 75 for output.
Yeah. Sonnet comes in significantly lower, $3 for input, $15 for output per million tokens.
Okay, quite a difference.
And the article also noted something interesting. Anthropic quietly retired the Haiku tier with this launch.
Ah, okay.
It seems Sonnet's basically evolved to cover that ground now, probably offering a better mix of speed and cost than Haiku did.
And that seems to be driving adoption already, at least according to the article.
Yeah, apparently major developer platforms like Cursor, Replit, GitHub, Copilot, they flipped their default models to Claude 4 Sonnet almost straight away.
Really? What?
Citing its cost-effectiveness for those common coding assistant tasks, it just hit the right balance for them.
Gotcha. And speaking of cost, there was this other feature the article flagged as a big deal for practical billing, prompt caching.
Oh yeah, prompt caching. They describe it almost like a stealth discount.
Self-discount? How so?
Because it can apparently shave off up to 90% of the cost during long iterative sessions with the API. It remembers recent prompts and avoids recomputing.
90%. Okay, that's significant.
Yeah.
So we've met the family, Opus and Sonnet. Let's get under the hood. What are the specific technical innovations the article points to, the things meant to tackle that reliability challenge?
Right. This is where it gets really interesting and honestly pretty clever.
Yeah.
The article highlighted several key architectural changes.
Okay.
First was this idea of hybrid instant versus thinking modes.
Instant versus thinking.
Yeah. When you send an API call, it starts in an instant lane, good for quick, simple responses. But if the system detects complexity, maybe it needs multiple reasoning steps, tool calls, chain of thought, it automatically shifts that request to a thinking lane.
So it's like adaptive latency. It only ramps up the thinking power when needed.
Exactly. There's a tiny delay, maybe a few hundred milliseconds when it switches, but that's what unlocks the model's full problem-solving muscle.
Can developers control that?
They can force it with an extended thinking flag if they know a task is complex, but the auto toggle seems to work well usually, saving front-end teams a lot of guesswork.
That sounds smart. But the feature that really jumped out in the article, the big headline upgrade, was parallel tool calls.
Oh, this is a game changer. It fundamentally changes how agents work compared to the old way.
How so? What's the old way?
Well, normally an agent might say, okay, step 1, search, then it waits. Then step 2, parse results, waits again. Step 3, run code, wait. You get the idea? Sequential.
Right. One thing after another.
Yep.
Very slow.
Exactly. Yeah. Claude 4, as described in the article, launches all the needed subtasks at the same time. It can hit multiple APIs, run different code snippets, do several searches simultaneously.
Oh.
Then it gathers all those results and reasons over the combined information in one go.
What does that actually feel like? Did the article give an example?
They did. A complex literature review task.
Yeah.
Something that used to take maybe 6 minutes, step by step,
Uh-huh.
with parallel calls. They said it finished faster than your coffee cools down.
Seriously?
Yeah, they framed it as this speed gain so massive, you didn't even realize how much the old way was slowing you down until you saw this.
That definitely sounds like a huge efficiency jump.
Yeah.
And combining that with the cost stuff, how do the prompt cache and batch endpoints fit into the actual cost picture?
Right, so the article detailed how that prompt cache endpoint essentially fingerprints prompt response pairs and keeps them handy for about an hour.
Okay.
If you send a similar query again, it often just streams the answer from disk. No new computation, no burning tokens. Pair that with batch posting, sending, say, 50 prompts in one go instead of 50 separate calls. And the article's takeaway was that these features can make your token meter feel like a rounding error.
So the list price per million tokens is one thing, but the actual invoice at the end of the month could look dramatically different, potentially much lower.
Exactly. That's where they suggested the finance teams really start paying attention. The effective cost per successful task becomes much more predictable and often way lower.
Makes sense. Okay, another thing developers always want is persistent state, right? Memory beyond just one turn. How does Claude 4 handle that?
They explain it using memory files. These are basically typed JSON files linked to a user ID.
Okay, like a little database.
Sort of, yeah. It gives the agent or app a structured, persistent state. The model has some smarts to figure out what's relevant from the files, but developers can also pin or delete entries.
So you have control?
You do. And the article suggests that this allows agents to build up this kind of shorthand context over time. It starts to feel like working with a senior teammate who just remembers past stuff.
That sounds really useful.
They felt it was a key differentiator for building robust enterprise pilots, moving beyond just simple stateless demos.
Speaking of robust and long-running, the article mentioned something pretty wild about session length, 7-hour sessions.
Yeah, this was tied to a specific anecdote they shared, the Pokemon Emulator test.
Pokemon Emulator?
Yeah, in their internal stress testing, an Opus-powered agent was able to plan, code, and even run unit tests for a mini Pokemon emulator project for 7 hours and 18 minutes straight.
Without any human help.
Without any human intervention. That's what they reported.
Wow, 7 hours is way beyond what previous models could manage, right? How do they do that?
The article put it down partly to a keep alive stream pinging the system every 50 seconds to avoid timeouts, and crucially, that efficient cache reuse we talked about.
Ah, so it wasn't constantly reprocessing everything.
Exactly.
Yeah.
They framed this less as a flashy demo and more as like R&D proof for what they call the overnight agent.
The overnight agent.
Hinting at a machines that could tackle entire complex projects or write big reports unsupervised while we sleep.
That level of sustained autonomy is pretty compelling. Okay, and finally on the architecture side, safer chain of thought. What's that about?
So by default, if you ask the API for the model's internal reasoning, it's chain of thought.
Uh-huh.
It gives you a concise, summarized version.
Okay, not the raw step-by-step.
Not by default. The article saw this as smart and gives you transparency on how it got the answer, but without potentially leaking sensitive details from the prompt that might show up in the raw thoughts.
Ah, like protecting PII or something.
Exactly. They noted enterprises can pay to unlock the full unredacted logs if needed.
Okay.
But for most teams, the default summary strikes a good balance. They link this directly to Anthropic's safety charter, trying to mesh compliance needs with interpretability.
Okay, so those are the key features. But, as the article also pointed out, engineers care less about cool demos and more about error logs and performance numbers, right?
Absolutely. Reliability.
So how did Claude 4 reportedly stack up there?
This is where the real-world data cited in the article gets pretty convincing. They reported some solid quantitative wins.
Like what?
On hallucinated function names, for instance. They saw almost a 60% reduction compared to using OpenAI's O-series on the same code.
60% fewer fake functions. That's huge.
It really is. And those parallel calls. dropped the median runtime for their internal ETL jobs by 40%.
40% faster. Nice.
And the prompt cache, as we said, cut their cloud spend on iterative tasks so much. The article joked that finance and engineering finally share the same lunch table.
Huh. Okay, so real measurable improvements. How did that translate to the benchmark tables the article showed?
Well, the May 2025 benchmark table they presented, it told a pretty clear story. Opus really took a victory lap. Came out top in 4 out of the 6 charts they showed. The article suggested this was down to its longer thought budget.
Longer thought budget, meaning?
Basically, it could spend more internal compute cycles on searching, reflecting, retrying complex steps, more thinking time.
Got it. But there was a surprise in there too, wasn't there?
There absolutely was. Sonnet, the much cheaper model, remember, actually edged out Opus on SWE-bench.
The software engineering benchmark. Huh.
Yeah. The article pointed to this as proof that careful distillation still matters. Sometimes a smaller, focused model can beat the giant generalist one on specific tasks.
Interesting. And how did they compare against the competition like Gemini?
The article acknowledged Gemini's massive 250K context window still gives it an edge for pure, raw context tasks.
Like just stuffing tons of text in.
Exactly, like multilingual trivia where you just need sheer capacity. Claude's 200K is big, but Gemini's bigger there. But, the article stressed, Gemini's relative lack of features like built-in caching and parallel tools made it slower and less efficient for compound tasks needing multiple steps.
Ah, the workflow stuff.
Right. The overall conclusion from the benchmarks in the article was that Claude 4's design choices, tool orchestration, caching were actually tilting the scores.
Yeah.
The practical usability advantage was leaking into the raw performance numbers.
Leaking into the scores. I like that. Okay, benchmarks are useful, but the article also included specific anecdotes, right? The lived experience of using it.
Yeah, this is where it gets more relatable, less abstract. They shared a few examples.
Okay.
There was the zero drama email. Using Opus to draft a note about a broken espresso machine.
Huh. A critical office task.
Totally. Only 72 words, but perfectly pitched. The VP replied positively almost instantly. Sounds simple, but nailing that tone reliably is actually pretty hard.
It really is. What else?
The Solar System Explorer. Using Sonnet, they generated a full 3JS bundle for an interactive 3D solar system model in under 12 seconds.
Wow.
Had all the facts, correct orbits, just 312 lines of code. Pretty impressive speed and quality.
Definitely.
Or the student finance dashboard example, where Opus apparently shipped a fully wired React app with data persistence and 0 ESLint errors.
0 lint errors, that's the dream. Generating clean, functional apps, almost ready to deploy.
Pretty much. They also described taking an existing Babylon.js dungeon crawler game template
Okay.
and evolving it over just 5 prompts with Sonnet. But the cool part, they noted, the agent subtly auto-downsized textures for better performance without being told to.
Whoa, proactive optimization.
They called it a subtle flex, showing some embedded intelligence beyond just following orders.
That is a flex. And of course, that 7-hour Pokemon agent test we mentioned.
Yeah, that served as the poster child, as they put it, for real-world stamina reliability in these tests.
So these field tests, while maybe not rigorous science, they reveal how the features actually feel and behave day to day.
Exactly. And based on all this, the article outlined what it saw as the ideal use cases for Claude 4 right now.
Which included things like enterprise coding assistance.
Yeah, backed up by that rapid Sonnet adoption by GitHub Copilot and others.
Research agents.
Right, where the big context plus memory files make long-running analysis much more feasible. Think literature reviews, document deep dives.
Operations dashboards.
Yeah, using Opus maybe on a schedule, like a cron job, to generate human-readable summaries from complex data.
Voice-first personal workflows.
Integrating the API to quickly triage email, tag tasks, draft documents potentially faster and more naturally than dictating everything yourself.
And creative copywriting.
Yeah, marketing teams apparently found the Output Pros remarkably human-like and brand-aligned, cutting down editing time significantly.
Okay, so lots of potential wins. But the article used that great phrase, no silver bullets, just fewer dents. It's not perfect then.
That was their pragmatic take, yeah.
Yeah.
Very strong, but not flawless. They had a comparison table highlighting where others still have an edge.
Like context size.
Exactly. Gemini still leads there at 250K tokens versus Claude 4's 200K. So if your task literally just involves cramming in the absolute maximum amount of text at once, Gemini might still be the tool.
Okay, but where did Claude 4 pull ahead in their direct comparison?
On those key features for complex workflows and efficiency. Parallel tool calls, Claude 4 has it, others don't.
Right.
Long horizon runtime Claude 4 at 7+ hours, way ahead of others, reported around 1.5 hours.
Big difference.
And the memory API Claude 4's structured files feature seemed more mature than OpenAI's beta notes or Gemini's lack of a built-in equivalent.
Gotcha. And what about price again? We saw the token costs.
Right. The raw price per million output tokens for Opus 75 is higher than O340 or Gemini 36.
Okay.
But the article strongly reiterated that Claude 4's caching feature dramatically changes the real cost for iterative tasks. Sticker price looks high, but effective cost per job, often lower.
And the coding benchmarks.
Claude 4 reported as leading there, particularly Sonnet showing surprising strength.
So the takeaway from their comparison seemed to be, teams building actual applications are often prioritizing Claude 4's unique features. Parallel calls, memory, long runtime over just raw context size, or the absolute lowest raw token price.
That's exactly what their feedback suggested, yes.
Yeah.
Those workflow enhancers were proving more valuable in practice.
Okay. And what about the dents, the caveats the article mentioned?
Well, the 200K context ceiling, while large, can still be hit if you're trying to dump, say, a year's worth of PDFs. And there are rumors of future models doubling context again, so there's pressure there.
Sure.
No native image generation built in. Getting the unredacted chain of thought requires an enterprise deal, which felt awkward for researchers.
Right.
Opus's high output price means you need to engineer your agents to be concise to manage costs. And they mentioned some early minor SDK glitches with parallel calls under heavy load, but said those were being patched quickly.
But overall, those felt like fewer dents than maybe with previous generations of models.
That was the article's conclusion, yeah. The issues seemed relatively minor compared to the big step up from the core features.
Looking ahead then, the article mentioned Anthropic's Teased roadmap. What's coming next, potentially?
They highlighted 3 main short-term goals. First, stretching that context window further, aiming for 400K tokens.
Doubling it again. Wow.
Yeah, the article speculated this might use techniques like reversible token compression. They cited use cases like law firms needing to process huge case bundles.
Makes sense. What else?
Second, moving to vector-based memory files.
Okay, what does that mean practically?
More semantic recall. Instead of just keyword search in those memory files, you could ask things like, find every time we discuss project timelines, and it could understand semantically.
Ah, much more intuitive memory access, like how we remember things.
Kind of, yeah.
Yeah.
And third, maybe the most intriguing, an on-device mini-Claude.
On device, like running on my phone.
Exactly. A distilled version of Opus, designed to run privacy first, potentially offline right on flagship mobile phones.
An offline Claude on your phone? That feels like a pretty big shift.
The article noted that hitting even 2 of these goals would significantly widen the gap Claude 4 currently seems to have. And on-device inference. That could completely change the conversation from cloud latency and cost to things like battery life and local compute.
Definitely changes the landscape. Okay, finally, the article wrapped up with what they called the engineer's litmus test. What was the verdict there?
They framed it through the lens of friction. How often do you feel like tearing your hair out when integrating a new tool?
Huh, I know that feeling well.
Their experience with the Claude 4 API was apparently overwhelmingly positive. 5-minute SDK setup, clear docs, error messages that actually made sense.
Good DX is crucial.
Absolutely. And the feeling of setting up those parallel calls and seeing them just work, they compared it to the excitement of compiling Quake back in the day.
That is high praise from an engineer.
It is. But the subtle sign of maturity they flagged was really interesting. It was how the model interacted around unit tests. It wasn't just spitting out code. It was writing tests, adjusting them based on feedback, even reminding the developer about version tags needed in the prompt.
Like a helpful collaborator.
Exactly. That behavior, they felt, signaled a level of understanding and helpfulness beyond just code generation. It didn't gaslight the user, as they put it. It felt like a partner.
And the ultimate test of developer experience. Which model did their engineers actually default to using day to day?
After 2 months of using both across their team, the article observed a clear internal default emerging.
Which was?
Engineers consistently reached for Sonnet first, unless a specific, massive context limit absolutely forced them to step up to Opus.
Interesting. So Sonnet hit the sweet spot.
It seems so. The combination of reported reliability, the good developer experience, those key features like parallel calls being available, it just became the path of least resistance for building things.
So to wrap this all up then, based on what we've unpacked from this article, Claude 4 isn't just being presented as another chatbot iteration.
No, definitely not.
It's explicitly positioned, and according to these findings, actually performing as reliable infrastructure.
Hmm.
Those powerful new features, parallel tool calls, smart caching, persistent memory, they seem to translate into real, tangible gains.
Significant gains, yeah.
Huh?
In developer experience, overall application performance, and importantly, real-world cost efficiency.
It sounds like it's directly addressing that core pain point of unreliability that made earlier models, even impressive ones, sometimes feel capable but ultimately a bit.
Fragile.
Exactly, moving from fragile tools towards dependable infrastructure.
Okay, so considering this leap in long-horizon autonomy, we talked about agents working for hours unsupervised and the roadmap with vector memory for semantic recall, even on-device models. Here's a provocative thought for you, the listener.
Okay.
If AI models can increasingly handle these multi-hour complex projects or recall context semantically across long tasks, how might your role need to adapt?
That's a big question. Could it shift? Maybe less focus on direct task execution and more towards higher level direction, oversight, defining the right problems for the AI to solve.
Becoming more of an architect, maybe.
Perhaps. And what entirely new kinds of ambitious projects before lunch could you suddenly tackle now that you have these kinds of capabilities potentially at your fingertips?
It definitely asks us to rethink our partnership with these tools, doesn't it?
Yeah.
And what becomes possible when they handle the grunt work more reliably.
It really does. Well, thanks for joining us on this deep dive into Claude 4.
My pleasure.
We hope this gives you plenty to think about and maybe even explore regarding the potential of these new capabilities in your own work.